All right. Welcome, everybody, to Standing for Truth. My name is Donny, and I am your host and moderator for tonight's live event. And we have a real treat for you tonight as we have an in-person debate, as in Dr. Dino and a special guest, Grayson from Based Theory. Good to see you, gentlemen, for an in-person discussion. And so let's just kind of get right into it. We're discussing, is there good scientific evidence for evolution? Dr. Dino, good to have you. Let's start with you. Brief introduction and kind of kick off this event for us.
Well, yes, thank you, Donny, for having me on again. I'm been a Baptist preacher 49 years, almost 50, and we're in Lenox, Alabama, at Dinosaur Adventureland at Genesis Baptist Church. I feel a little bit like St. Peter when he was up in heaven, and one day a politician and a Baptist preacher came up to heaven. They died, and they wanted to see where they're going to live. So Peter took them over, and the Baptist preacher got a little cottage over on the side. The politician took the politician first and had this giant mansion he put him into, and took the Baptist preacher over and took him a little bitty cottage. He said, "What's going on here?" I thought, I get something better than a little cottage. Peter said, "Well, we get Baptist preachers up here all the time, but to get a politician, this is the first one we've ever had." So we gave him the big house. So good to have Grayson come visit. Popped in this morning, and visited our church and took him on the tours today at Dinosaur Adventureland. We're in Lenox, Alabama, straight north of Pensacola, 70 miles. Come on down, 140 acres where God gets the glory for his creation. And I always start off saying, if you want to support our ministry, we're open for free. Join our 777 club and help us out if you want to stay at drdino.com. 7.773 years now. Lots of visitors from all over the world. We love this place. So tonight, impromptu debate. Grayson, thank you so much for coming. You just showed up out of the clear blue. You've been around DAL now and taken all the tours. Is this a cult?
Yeah, I'm going to plead the fifth on that one. But I want to say I don't take too kindly to being compared to a politician or a Baptist preacher. Okay. But other than that, I did have fun on my tour today, especially seeing all the animals at DAL. Narrowly surviving your driving in the Jeep. And there were a few real science demonstrations that I thought was quite fun, like the focal points and the sound carrying over distance. And there was a few other things I would not classify as real science that we can talk about tonight.
Okay. Would you recommend other atheists come visit and bring their families?
That's their prerogative. I'm not going to tell anybody what to do, but I had fun.
Okay. Now, you had some atheists advise you not to come here because you might be dangerous. There's a bunch of people with guns and rednecks. And what do you think?
Well, I felt quite safe. Everyone was very hospitable.
Okay.
So thanks, Kent. He put me up in one of the cabins on property and fed me. So I'm a happy camper.
All right. Would you give my audience, Joe says we got a whole bunch of people on all the different platforms watching us, like thousands and thousands. What is your worldview? How did the world get here? We talked about it some going to Chinese restaurant. What's your worldview with the atheism? How did we get here? Why are we here? And all that stuff. Go ahead.
Yeah, so I guess atheism is not really a worldview. It's just a lack of a belief in God. But generally, I would be a naturalist, a physicalist. I accept the scientific consensus on things like the Big Bang, the development of the solar system, evolution. And so that explains, how humans evolved from more basal primate ancestors to where we got today. And the general stroke of history for the human species over, 300,000 some odd years, the development of civilizations, et cetera, modern archaeology, biology, physics, pretty much accept the scientific consensus on these things.
Okay. We talked a little bit of length today about the Big Bang Theory. Tell us what exploded, where was it, where did it come from, and what happened before that?
Sure. Okay. So we'll start with an easy question then, the origin of the entire universe.
Sure.
So first of all, the Big Bang was not an explosion. An explosion is a very well-defined phenomenon that the Big Bang does not fit into.
Okay.
The Big Bang was simply the expansion of space and time from a point that was much smaller and denser with energy. So our modern physics and math can only trace that back up to a certain point in which we don't have the proper math or the physics to describe those very first earliest moments. So all we really have is the evidence, which is very strong, that the universe was once in a hotter, denser, smaller state.
Okay, what is the evidence that the universe was in a hotter, smaller? Just the redshift, the expansion?
Redshift and expansion is one of those lines of evidence, but the one that I would actually consider to be the strongest would be the cosmic microwave background, which is a microwave signal that we can detect in the sky, and it's very homogeneous to about 1 part in 10,000, 100,000. So it's very homogeneous in every direction that we look, and there's no other physical explanation or mechanism to how that could be other than that this light originated back when the universe transitioned from purely plasma to molecular clouds of hydrogen, helium, and a little bit of lithium. So that's the only physical mechanism that we know of that could possibly explain the cosmic microwave background.
Okay, so as you mentioned, we don't have the physics or math to know before that or exactly all the details. So until we do, should it be taught as science in class, or should it be excluded from science class? And should we teach all religions? Because other people believe differently,
Well, obviously, I would take umbrage to you calling it a religion.
Okay.
I would say
you believe it happened.
Well, I accept that that's what the evidence supports.
Okay.
So there is evidence, to support at least up to the cosmic microwave background. And, even before that, there are properties of the cosmic microwave background. I don't know how in-depth we want to get here, but there's something called a power spectra, where it's an exact pattern. It's a certain attribute for the distribution of this temperature fluctuations. And it was predicted to extreme accuracy using just 5 or 6 free variables, using the math that has, a Big Bang 13.7 billion years ago. They were able to precisely predict what that power spectrum of the cosmic microwave background should look like back in the 70s. And we were not able to measure it adequately until the 90s and early 2000s, when it confirmed exactly what was predicted. So that's the gold standard of scientific evidence: is testable, repeatable, verifiable, falsifiable predictions.
Good. Is it an option at all in your mind that maybe what they're saying is, and God said, let there be light? Could this be the voice of God doing this? Instead of a Big Bang, could it be the voice of God?
So I don't know what mechanism that would fall under. So to me, that sounds like a supernatural miracle. And in science, science is methodologically naturalistic. So all of our hypotheses and theories in science are naturalistic theories.
Right.
So I don't know what natural mechanism would explain God speaking this into existence, but if that is the case and God created it all with the Big Bang, then that just sounds like more of a mainstream Christian view that I don't have as much of an issue with, because it follows the science. It's not pseudoscientific.
Okay, if there was this rapid expansion of all this particles being formed and everything from the plasma or whatever, every microsecond you wait, they're getting further apart at radial directions. How do you get them back together to make planets and stars? I mean, they're all getting further apart. Shouldn't it be one homogeneous dust cloud out there?
Well, there's this thing called gravity, Kent.
And where'd that come from?
Where did gravity come from?
Yeah, who made gravity?
It's a phenomenon in the universe. I don't know where it came from. But we observe it happening. We know it's a real phenomenon.
I believe in gravity. I use it all the time. I'm using it right now.
There you go.
Sitting on a chair. So gravity, as they get further apart, you probably know the inverse square law, the gravitational attraction becomes weaker and weaker. That's why I wonder, why isn't it just one big dust cloud? How did anything get together? Because every second you wait, they get further apart.
Yeah.
Why did they suddenly turn around and go back together?
It's because forces such as gravity keep them in a bound state. So even if there's a metric expansion of this space in between all the atoms in my hand right now, the atoms are being held together by forces. In that case, it would be the chemical bonds and the electromagnetic forces holding all those atoms together. So those atoms, even though the space between them, you could be having a metric expansion, they're continually going to be held together by that force. So gravity, in the instance of more of a cosmological scale, would be what's pulling together material into stars, planets, galaxies, etc.
So if we release a dust cloud now, like all the factories in the world are doing, do they get together and form solid objects and fall down? Does all the smoke coming out of the factory become a lump and fall down?
Well, they are under the influence of the Earth's gravity, so they're not going to be escaping out into space. They're going to be kept within the Earth
I'm
system.
not talking about attracting to each other. It's a whole lot of dust coming up. Why does it make a cloud? Why not clumps,
Right. Well, you cited the inverse square law before. You would know that in the numerator of the universal law of gravitation is mass. So something that is, as light as just the amount of mass in gas that a factory emits is not going to congeal into an entity with its own gravitational field.
But the initial Big Bang, it did work. All these particles, if you want to call them particles, flew out and then got back together to make stars and planets. And all rotating and in pretty cool orbits and stuff. That all happened by gravity.
Well, gravity is certainly one factor. There's also, like, if you're talking about explanations of planetary motions and spins, then you have their past histories. So you can have collisions that can knock planets off of their spin axis or cause them to spin in opposite ways. And the past collisional history of these bodies come into play. But I would just describing the Big Bang as all these particles just flying out from some centralized point is not really the picture that is the consensus. I mean, the Big Bang did not just happen at one point in space. The entire universe was on a much smaller spatial scale and was much denser. So the Big Bang was happening at every point in space. Every point in space was at one point in time a plasma of quarks and gluons, etc. So this was happening at every point. There's no central point, no center. Every point was experiencing this same metric expansion.
And where did space come from for this to expand into?
Right. So we do not have good answers for that at the moment. I mean, there are literally ideas in physics that on the breaking forefront of physics right now, asking that very question about could space and time be emergent from some more fundamental physics? So the question you asked is very profound, and it's, theoretical physicists are working on that question even as we speak. So I don't have an answer for you, and neither do the physicists at the moment.
Well, here is the European Space Agency. They said time, space, and matter all began with the Big Bang. In a fraction of a second, the universe grew from smaller than a single atom to bigger than a galaxy. So you and I and this cup of water were all in that dot, smaller than an atom. That's your position.
Yep.
Okay. And the whole world, the whole Pacific Ocean, Mount Everest, everything was in that dot. Does that not seem a little far-fetched to you?
No, because when you can condense regular matter like that you or me or whatever are made of, what you get is eventually you're going to compress it so much that you're just going to have the cores of those nuclei, and you're going to continue to compress it, and eventually the protons and neutrons themselves are going to break into a quark gluon plasma. So you can condense all this material into a very, very small volume of quark gluon plasma. And when you continue to compress that, you need more of a unified physics to describe how that behaves. Right now, we've been able to produce quark gluon plasma in particle accelerators. We have, again, this was a tested, verified prediction, a hypothesis, and that we have measured it themselves. We've tested its properties. We know it's real. So it's empirically verified that, if you compressed everything here, you would get a very, very small volume of quark gluon plasma, and you could, in theory, continue to compress it. If we had a more powerful particle accelerator, we could probably tell you what that would compress down into.
So if a bunch of smart scientists build a really fancy machine to compress the particles, that's proof that nobody made the universe.
That is empirical evidence that it can, in principle, be compressed.
Okay.
This is not saying that any agent or any mind was responsible for compressing all this material. The material was compressed because, obviously, when we look around, we can see that space and time are expanding. Right. If you track that back in time, it's getting smaller and smaller and smaller. So you have the same amount of energy in a much smaller area. So there's the compression.
So that would be an awful lot of energy. All of the stars are producing an awful lot of heat. Mm-hmm. Our sun produces a lot of heat. Okay. Mm-hmm. All that energy was also in that quark gluon plasma.
Yes, that's about it. It would be very, very hot.
And who heated it up? What stove was that cooked on?
Well, there was no stove.
Okay.
As far as I know, I don't know of anyone who was heating that up.
So you start off with an extremely hot, extremely dense dot, smaller than an atom, like European Space Agency says, and that grew to be everything. There's Forbes magazine said it was the size of a human being. Of course, they're outdated. It should be really a dot, right? But they all say this. American Museum of Natural History. The Big Bang, 13.8 billion years ago, universe began as a tiny, dense fireball that exploded. They probably should not have used the word exploded because that.
I agree.
So you need to call them up. American Museum. American Museum of Natural History. You want to write that down? So you look, correct them.
Sure, I'll put a complaint.
Put in a complaint, correct them. So I point out, like this one, the universe from nothing. SciTech Daily. It came into existence around 1/10,000th of a second after the Big Bang. The tiny particles that make up atomic nucleus came up 1/10,000th of a second after. Now, would it be okay with you if some people on this planet who have to share the planet with you and I don't believe that and don't want their kids taught that? They say, look, that's not science. It's not testable and provable yet. The fact that somebody could do it in the laboratory does certainly not mean it did happen in history. Why do we all have to pay for this stuff to be taught to the kids like it's part of science when, even if it's true, it hasn't been proven yet?
Well, it has evidentiary support. So again, the Big Bang model, as we understand it, has made predictions that have been verified. So that is meeting the gold standard of science. And again, nucleosynthesis, which is what you're talking about, which is like the development of like
atomic particles.
Yeah, atomic particles, nuclei, atoms, etc. There are certain predictions within the math of the Big Bang model about there's certain ratios. And we have seen that when we look around, we see confirming what was predicted by the Big Bang model. So there is evidence to support this, and it is following the scientific method. So I would say that qualifies it to be taught as science.
Okay, when was the red shift discovered approximately? Do you remember?
It would be like Hubble back around the 20s.
Okay, 1920s. I could read this Bible here and find 17 times where God said the stars were stretched out into place. The Bible says God made the earth, 2 days later made the stars and stretched them out. I could have predicted by reading this book before Hubble discovered it that there would be a red shift, because red shift is the Doppler effect of light, the change of velocity and stuff like. So if I had made that prediction before, I wasn't born in 1920, but if I'd made that prediction from this book that, hey, there's going to be a red shift, and sure enough, they come along and discover it. Wow, that proves the Bible's right. God stretched out the heavens. Would that be then science?
So I'm not an expert on biblical scholarship or Bible verses, but it's my understanding that those verses all use the past tense for stretched. And then our observations, like in 1998, it was observed that currently the expansion of the universe is actually accelerating. So not only is it expanding right now, but its expansion rate is accelerating right now. So I don't know if I would necessarily count that as a verified prediction if it was in the past tense. Again, I don't read the original Hebrew. I'm not an expert on this, but I would also say that hallmark of scientific predictions is that they are repeatable.
Right.
So I don't know. I mean,
so do another Big Bang then, make another universe.
Well, we can do repeatable observations of things like the cosmic microwave background, or like the Hubble flow, which is the relationship between the distance of galaxies and their rate of redshift and Doppler effects.
Okay, so if the universe is accelerating, where's this new energy coming from to accelerate it?
Well, you're hitting on another frontier of physics. That's dark energy. So currently, it's a big question mark in physics right now. Dark energy, we don't know what that is.
We have to just imagine that it's out there and that it happened. Okay.
Well, there is solid evidence for dark energy. We don't know what it exactly is composed of or all of its properties, but not just the expansion of the universe accelerating, but even when they do analysis of this cosmic microwave background, there's something called like the Sachs-Wolf effect that essentially hints at this dark energy from even back at the cosmic microwave background. So there are independent corroborating lines of evidence, at least showing us that there is this dark energy something out there, but it's not well characterized, although we do have evidence it exists, similar to dark matter.
But it's not God.
I don't think so, because it's naturalistic for all that we can see.
We don't know what it is, but we know it's naturalistic, even though we don't know what it is.
That is methodological naturalism. It's a hallmark of science. If you want to say dark energy is God, to me, that seems strange. But if that's what your God is, dark energy,
I don't believe that for a second.
Okay.
But I just think if it take a lot of energy to push a star, they're pretty heavy.
Yeah.
Okay. And to accelerate them, gee whiz, what kind of gear shift you got on that, kind of transmission and all that stuff, the drivetrain, gee whiz. So that would take a whole lot of energy. And all that energy was also in that dot, smaller than an atom, right?
Again, with dark energy, it's very hard to make any kind of solid statement like that about especially how dark energy changes throughout the history of the universe's development. So I don't know how to answer that question.
So we don't know what it is. We don't know where it came from. We don't know exactly what it's doing, but we got to teach it to all the kids that this is science.
Well, to my understanding, dark energy is not taught in public K-12 education.
The Big Bang sure is, man.
Yeah, but the Big Bang, I mean, we knew about the Big Bang long before we knew about dark energy. So,
well, the major evidence for the Big Bang for decades has been this redshift.
So
the stars seem to be receding, and I would agree with that. Based on the redshift, it looks like all the stars are racing away from us. Almost like it started from us on Earth, and then God made the stars and stretched them out, like my book says. I guess I don't see a conflict there between that and this and the science.
Yeah, so in the history of the development of the Big Bang, like Hubble's observations with the redshifts and how they correlate with distances, that was a major evidence that was being used for the Big Bang. But it wasn't universally accepted in the field until the observations of the cosmic microwave background. And for physicists, that was pretty much the final nail in the coffin of, now everyone basically acknowledges the Big Bang because the cosmic microwave background is such strong evidence for it.
Okay, so if I go down here to Interstate 65, 4 miles away, and I see a car headed toward Mobile, Alabama, 100 miles away, or 90 miles. Does that prove, and they're going 70 miles an hour toward Mobile, does that prove they started in Montgomery hour and a half ago? Or could they have just got on at the last exit?
No, yeah, of course not.
No way to know, right?
Yeah.
So could the red shift have started, God made the earth, made the stars, stretched them out, and Adam and Eve see the taillights of the stars as they're heading away, and it all started 6,000 years ago?
Well, if there was any evidence to support that, then I would certainly pay attention to the evidence. So all scientific theories and facts are provisional. They're subject to change if new evidence comes out that shows that they were wrong. So right. I'll be open-minded to any evidence, but as long as I'm not seeing any evidence to support that, then that seems to be the proper paradigm.
Okay, I do appreciate that you're open-minded and that you come here and look at our place and they got nothing to hide here. That's why we're going to get you converted. You keep that open mind, we're going to drop God in there, okay? All right. Okay, so my objection has always been they teach this Big Bang stuff like it is part of science, and there's so many things about it that are not answered yet. And even if it's true, like I said, until it's proven, it shouldn't be taught in a science class because other people object to that. Millions of people don't want their kid taught that stuff. So why do we all pay for it?
Well, like I've said, it does fulfill the golden standard of science, which is testable, repeatable, falsifiable predictions that have been shown to be accurate.
Well, if it's repeatable, have another Big Bang. I'd like to have my own universe. Make me one.
The predictions for the observations are repeatable.
Oh, okay. So I can't have my own?
You can repeatedly observe the evidence that shows that the Big Bang happened.
Yeah, okay. Let's see. So then the next step would be, once we get the Big Bang that made all the material, now we have to get it collected into planets and stars, which you think gravity did all of that.
Sure thing.
And somewhere along the line, I think you would agree that there are living things on this Earth plant life, animal life, human life, that are different than the rocks and minerals.
Yep.
Okay. How did life get started in your theory?
So abiogenesis is another one where there is no current scientific consensus. It's one of the biggest open questions in science. There are several competing hypotheses like RNA world, protein world. My own personal favorite hypothesis is called amyloid world. It's a little bit lesser known, more niche, but it's just my personal favorite. I'm not saying it's really how things happen. I just think it's a very neat theory. But we don't have... when a hypothesis starts garnering more and more evidence to support it, it can graduate to a theory.
Sure, right.
We do not have yet a theory of abiogenesis. So we only have competing hypotheses, but nobody has a complete mechanism to explain it. But just the general picture is that you need for Darwinian evolution to kick in to start developing the complexities of life. So you need a few basic things for Darwinian evolution to kick in. You need a self-replicating population. This could be like a chemical system. This could be like an amyloid, which is a type of protein, or an RNA, or a metabolism of chemicals, whatever. Something that is self-replicating.
That's awfully complicated right there, but go ahead.
Yes, but we have seen self-replicating chemical systems come about naturalistically. So you need a self-replicating system. There needs to be some manner of inheritance and some amount of variation that has different fitness effects. If you have those characteristics, then Darwinian selection kicks in as a process, and you can see complexity and adaptations and things evolve.
Well, maybe you can tell me, I'm going to show you what you've heard me teach in my seminar on this before, but show me where these people are wrong. National Geographic, the Earth formed 4.5 billion years ago. It was a uniform ball of hot rock. Do you believe that?
Uniform, for a layman person's perspective.
Well,
sure. I can agree with that. It's close enough. It's like 4.65 billion years ago. It's not exactly uniform, but yes, it's basically right.
Then here's a fact monster. I don't know what they are. Earth began as a ball of molten rock. So this was still really hot. All these particles that from this big expansion, the Big Bang, got together to make an Earth about 8,000 miles in diameter. And gravity pulled it into a round shape. It is not flat. By the way, thank you for debating the flat earthers. You flat earthers, knock it off, okay? You're embarrassing Christians, all right?
I just want to say that this is a point that Kent and I can very much agree on, that the flat earthers are silly. So I wish, Kent, I have debated several flat earthers myself. I wish that you would use your talents and skills to redirect it from the science and redirect it to the flat earthers and debate them. I would love to see a debate with you and a flat earther.
First of all, don't redirect it from science, because evolution is not part of science.
Well, we disagree on that.
I redirect it from evolution. I love science. We got a science center. You toured it today. Okay, so you agree the Earth was a hot ball of rock. Here it is from answers. This is story maps, whatever that is. Earth formed as a hot ball of rock. They're all saying this. Answers.com, whatever that is. Earth was a hot ball of melted rock orbiting the sun, and the Earth cooled off and a hard, cold, brittle crust formed. Is that a reasonable summary of what you believe? Okay.
Sure thing.
Okay. National Pornographic again. Earth began as a hot ball of rock. New evidence, this is from Universe Today. New research suggests when Earth was still a hot ball of rock, Mars might have been covered with warm blue oceans. Well, I'll get off on all that. So the textbooks teach, you can see all my textbook collection here, okay? They teach the kids the Earth began as a hot ball of rock. Now, Mr. Nelson from Texas, where you are, he calls himself R and Ra, the sun god. He said, no evolutionist ever believed we came from a rock. But all the textbooks do say it began as a hot ball of rock. So do you disagree with him, or do you agree that we came from, ultimately, somewhere, it took a long time, I know, but we came from a hot ball of rock?
Yeah, so when we say we, where we came from.
You and I, did we come from this ball of rock?
I personally don't follow the Gaia hypothesis. Okay. So when I say we, I'm not referring to the Earth. So all that was showing was the Earth was a hot molten ball of rock, but I don't think we came from that hot molten ball of rock, because the material that makes up our body is not rock, it's not largely minerals. It's largely organic molecules. And these organic molecules, which would have been that self-replicating chemical system that would have been composed of organic molecules. So the things that gave rise to life were not rocks. They weren't part of rocks. They were organic molecules.
So did they come from space?
We have seen organic molecules forming and being abundant in space. They're called polyaromatic rings, and we can go and look in space in like space dust on comets. They're full of these organic molecules. Surely you're familiar with like the meteorites that they have analyzed and seen, hey, here's amino acids, here's some nucleobases. They're full of organic compounds. It's very abundant in space.
Well, so I want people to see what you believe. Okay. The Earth was a hot ball of rock, but the organic materials came from space. What made you and I was space dust, basically, landing on the Earth.
That's a fair characterization. Even Carl Sagan would say, you know, we are ultimately derived from space dust. So I think that that's more of a fair characterization than saying that we came from rocks.
Okay, so this textbook goes on to say 3.9 billion years ago, the Earth cooled enough for water vapor to condense, and Earth was experiencing violent rainstorms, and it accumulated in Earth's oceans. And in these oceans, 3.5 billion years ago, the first living organisms appeared. So you don't think that's how it happened? Would you help me correct this textbook at least?
Sure. Well, I think that we have evidence for fossilized stromatolites, which would be like single cell cyanobacteria, back to maybe 3.8 billion years ago. So this might need to be updated a little bit. But yeah, essentially, once the Earth cools down to a point where the water vapor in the air can condense and form liquid water, then yes, you can start to have abiogenesis processes happening in said water.
So all the rocks melted, and the Earth was a hot ball of melted rock orbiting the sun. This is from Berkeley University. I mean, you know, they're true. Oh, University of California. You lived in California. Okay.
Yep.
UC Berkeley. They got to be true. And the rains created the oceans, and swirling in the oceans was a bunch of soup, a complex chemical soup of living organisms. Let's see. I go through this all the time. So Earth started as a ball of rock, and then life got started from the soup from the oceans. But the water in the oceans looks to me like was dissolved minerals coming off of the rock. But you're saying it's also stuff from space landing in the oceans?
Organic material, organic molecules.
So this soup had the right consistency and the right molecules to then come alive.
Yeah, so when I mentioned that there are several hypotheses of abiogenesis, not all of them are just, this aqueous environment. Some of them are having like wet, dry cycles, like on clay or in shallow pools, or some of them are deep sea hydrothermal vents, which can have their own really complicated
chemical systems. Right?
Yeah, exactly. They have like proton gradients are generated on these hydrothermal vents, like this, similar to how our cells today do work by taking advantage of proton gradients that they create. These proton gradients are naturally occurring at hydrothermal vents, so they wouldn't have to create them in order to harness energy and do work. Okay. So there are different hypotheses for different areas. It wasn't just, general ocean environment. Okay. There's lots of different hypotheses, and we don't know which one is the correct one, if any of them currently.
Okay. Do you think students in a publicly funded science class should be taught each of those different hypotheses?
If they're interested in them. I don't think that I was taught in detail any of these until more of a college level in like biochemistry courses. But I think the general picture, right? We talked about the cosmic microwave background before. That would suggest that at one point the entire universe was filled with a somewhat uniform plasma. So we know that at one point the universe did not support life. And we know now that it does support life. So at some point, life had to arise from non-life. Now, science would say that there's a naturalistic mechanism for that. You might say there's a supernatural miracle involved, but at some point, life had to have come from non-life. So, whether or not you want to teach the different hypotheses for abiogenesis just to maybe let people know what's out there or not, or you just want to start with what we do know a very well-supported mechanism for, like the origin of species of life, which is evolution, then That's the prerogative of the textbooks. I wouldn't care either way if the textbooks are teaching abiogenesis.
So if a teacher decides, in my class, I'm going to teach the hot thermal vent, the life formed on clay, life formed in the ocean, could they also include God formed it?
So
that's another hypothesis.
But it's not a scientific hypothesis because it's not methodologically naturalistic. But I would have a problem if that teacher was trying to pass off like a hypothesis as fact.
Would you have a problem if the teacher was trying to pass off atheism as a fact?
Yeah, I don't think that atheism should be taught in a science class.
Okay, so then life finally gets started, and do you believe it was a single cell life form that started first?
Well, it would be, I think, classified as a protocell, but eventually, yes, you would get to a single cell. The most relevant one that we could talk about is called LUCA. It stands for the last universal common ancestor. So when you trace back all living things today, they all trace back to a common ancestor called LUCA. So that would have been a single cell that would be, more basal than any living thing today. So that would be the earliest that we would talk about in evolution.
Okay, so you're aware, of course, that we cannot go back, and you say trace back. How are you scientifically tracing back your ancestry to this LUCA?
So there would be a number of different methodologies. We could talk about genetics, and we could talk about the fossil record. So when we look at the fossil record, right, there is an order to it. And at the very base of this fossil record, in the very lowest layers, we see nothing but, like I mentioned before, stromatolites. These are fossils of single cell colonies. So the very earliest that we see is just single cells in the fossil record. So there's evidence on that front, and then there's evidence from genetics. What do all living things that are currently alive, what characteristics do they share genetically, morphologically? And that would allow us to reconstruct, a hypothetical model for what characteristics LUCA may have had.
Okay. Now, you said the fossil record is in some kind of order. I have pointed out many times, there really is no fossil record. There are fossils, but there's not a record. None of them talk. None of them have a date stamped on it. So we have to put our interpretation on the fossil. You're digging in the dirt, you find a petrified clam in the closed position. It does not talk. There's no number on it. We don't know how old it is by looking at it. How did they tell the age of fossils?
So there's a number of different methods that they can choose from, but one that I could list is looking if there's any igneous layers above or below it, because you can't necessarily date a fossil using radiometric dating of the fossil itself.
Let me explain for the audience. Igneous means ignited, something that's been burned. Lava is the most simplest one to understand.
Yeah.
It's rock that came from something that was ignited, igneous.
Yeah.
Okay.
So yeah, one of the three basic types of rocks, but igneous rocks can be usually radiometrically dated. So if you find a fossil in a certain layer, if you look above it and you see an igneous layer that dates radiometrically to 200 million years, then you know that that layer below it was laid down at some point prior to 200 million years.
So you're bracketing it.
Yes, you're giving a range.
Right.
Yeah.
Okay. That, of course, then assumes that the radiometric dating methods are accurate.
Sure. I mean, I think that they're generally reliable. We have tested it on things of known dates, like the Mount Vesuvius eruption that destroyed Pompeii. That has been radiometrically dated to within about 10 years. So
wait. So if I took a sample from the lava from Mount Vesuvius to any laboratory and did not tell them where I got it.
Yep.
Don't tell them a thing.
Yep.
How old is this lava? They would get the same number?
Yes, they would get around the same number, yes. And Dalrymple did a study on this, I think, in 1992, and then it was repeated in the early 2000s, where they did double blind, they sent the samples out, and they all got back around the same number.
And that was Vesuvius in recorded history.
Yes.
So if you did something that we think is millions of years old, they would also give the same numbers?
Yes.
You think so?
Dalrymple also showed that in
I
his.
can show you hundreds of examples where they don't get that. But
There are several creationist attempts to do this, but if you look down at the methodology of how they selected these samples, it was quite misleading. It was very clear that they were setting it up for failure, basically, in their sampling process. Like, if you do a method incorrectly, you can be sure to expect incorrect results.
But you know that the ones that match your geologic dates were done correctly.
Yeah, so
Could they also set it up to give up billions of years age and not be correct?
Well, so there's several methods that scientists do in order to make sure that they're not sampling from a contaminated sample, or they're sampling the right kind of sample that they know can be radiometrically dated. Like, you wouldn't date like a marine shell or something. There are certain things like bones, there are certain things that you won't get an accurate sample for. Like a recent volcanic eruption, nobody would ever date that, because we know that there's not enough daughter isotope developed yet to give an accurate dating. So nobody would date Mount St. Helens, because you would be using the method incorrectly if you tried to do so. There's lots of other examples of like radiometric dates cross-corroborating with other methods. Like, there's a famous shipwreck from the Bronze Age, the Uluburun shipwreck. They used dendritic dating, which is from tree rings in the logs of the ship. And then they used radiometric dating. And then they also compared what kind of Egyptian scarabs they were finding on the ship. And all three of them converged to the same basic dating range of the early 1300s BC. So that's cross-corroboration against three different methods, one that's even just a historical method.
Sure. So that's something within the last few thousand years. But this also works for billions of years?
Yeah, so there's two things on this. There's something called isochron dating, where you are making absolutely no assumptions about the initial state. They're not required to do an isochron dating test. And when you plot out the isochron, the data points, if they're in a straight line, that shows that there was no contamination. If you don't get a straight line, then you know that there was contamination. So this method, not only you don't have to make any initial starting assumptions, but the method will tell you whether or not your sample was contaminated. So this clears up a lot of the potential unknowns. And there's also samples like zircon dating, which is uranium to lead. And you know that there could not have physically been any lead in that initial sample, because zircon crystals, the actual crystalline structure on a molecular scale, cannot incorporate lead when they form. So when those initial zircon crystals formed, they could not form with any lead. People have tried to make zircon crystals with lead in them at formation. Nobody has ever shown that it's even possible. So we know there was no lead initially, and we can find lead now that all trace back to around the same 4.65 billion years. It's zircon dating that's giving us those very oldest dates for the age of the Earth.
Okay, we'll leave that for another debate. But now we've got your first life form in this warm little pond, a single-celled creature. Were there like trillions of these, quadrillions of them all over the world, or was it just, did we all start from one?
It would be a population of Luca, yeah.
Okay. And how did they learn to reproduce themselves? I mean, even single-celled reproduction is a really complex process.
Yeah.
The DNA is more complex than all the computer codes ever written by man combined. So this first single cell had that DNA code already in it?
So I wanted to be clear to differentiate between Luca and the first life, like in abiogenesis,
Okay.
right? Luca is not necessarily the first cell. It's just the last universal common ancestor to everything alive.
The first cell then.
So I'll answer with the first cell, right? So when we started, even before we had that cell, before we had protocells, we had a self-replicating chemical system. So the fact that it could replicate itself, that's like the very first thing that needs to be checked for the development of life.
Explain how did that come about? Do chemicals today replicate themselves and make exact copies? Is there anything similar to the code they see of the DNA? I mean,
yeah. So this is kind of getting to what I said. I said amyloid world was my favorite of the little hypotheses, and I don't want to say that this is absolutely how it happened, but amyloids are a type of protein that they grow by adding amino acids onto they're kind of like a pleated sheet kind of, and they continue to grow along the edges by adding more amino acids.
Adding them by chemical attraction? By what causes them to add this?
So there are chemical catalysts, like a certain type of volcanic gas can catalyze this reaction that will add more amino acids and continue to grow this amyloid sheath. And the way that they're added is that it replicates the order of the amino acids. So as it's going, that information is being replicated, not perfectly. And once it gets to a certain length, it will break. And then you'll have two versions that continue to elongate. And so you have this self-replicating behavior in amyloids that even have a certain amount of sequence information that is replicated in a sort of very primitive form of inheritance. And this is all before and without any DNA involved. So we know that there are certain chemical systems which do have the capacity to replicate themselves, have some level of inheritability, and can meet the characteristics necessary for Darwinian evolution, all even without the complex machinery of a cell.
So from your this adding more chemicals, is this like an accretion process? Is that
I don't think accretion would be the right word, but maybe like a precipitation or something. But the amino acids are being added onto the amyloid structure.
And where are they coming from to be added onto?
So as we already went over, amino acids are naturally occurring in the environment, like meteorites are chock full of them.
Okay. So these amino acids slowly get together and form this, they're calling it an amyloid, right?
Yep.
And then it breaks in half and has two.
Mm-hmm.
How do you get from there to them having a cell membrane, a nucleus, containing DNA? And that seems like a huge jump.
Right. No, it definitely is. So the lipids, which form like the cell membrane, are also naturally occurring. And lipids will naturally form just because of the characteristic they have with a hydrophilic and a hydrophobic end. They naturally form into these little bubble shapes, just like kind of a cell is. And amyloids.
For the audience here, okay, hydro means water, and philic means love, and phobic means hate. So some love water, some hate water.
Yep.
So they arrange themselves away from water or toward water.
Yep.
Okay.
And it doesn't take any designer. If you just dump a bunch of lipids into water, they will just naturally form these little bubbles.
Nobody made them hate the water or love the water. That part was also just
These are chemical properties.
came from the Big Bang. Okay.
They're electrostatic properties.
Okay.
But yes, so these lipids are naturally occurring in the environment. We naturally find them. And amyloids will actually associate with these lipid membranes. Like if you have a bunch of amyloids and a bunch of lipids, they will naturally associate together. And it's the same for like nucleoside triphosphates or something, which is sort of the building blocks for DNA. So like ATP is probably the most well-known one. It's like the energy currency of our cells today. And it's one of the building blocks of DNA. So like I said, we know that there are these proton gradients that can be taken advantage of in hydrothermal vents. We know that actually amyloids themselves have certain catalytic properties. They can catalyze not only their own replication, but they can catalyze other reactions like the hydrolysis of ATP, which is how our cells today take ATP and do work, is they hydrolyze those bonds and do work. So we know that amyloids are capable of catalyzing this reaction. So amyloids at least have a fundamental interaction with all of these basic building blocks. In terms of the full picture, every single step of the mechanism worked out to how you get just self-replicating amyloids to a full protocell and eventually to LUCA, nobody has that full mechanism worked out yet. So again,
you should teach it.
I think I've been very clear that I would be against any teacher teaching these mechanisms as fact. I think it should be stressed that these are just hypotheses and that there is no current consensus theory for abiogenesis. I think that any responsible curriculum would stress that.
Okay, I don't remember right now the atomic number of phosphorus, but the ATP, these elements that you're discussing getting together, quite a few of them are beyond carbon. And my understanding is they've been unable to fuse past iron. So if your Big Bang produced hydrogen, helium, a little lithium, how did we get all these elements from hydrogen? I'd like to make gold out of hydrogen. That'd be cool.
Yeah, so within stars, hydrogen and helium are fused into heavier elements. But you're right, a normal star will fuse up to about iron, which I believe is number 54 on the periodic table.
Iron 26, yeah.
26, yeah, 50, the weight is 54,
yeah,
yes. So, yes, 26.
Depending
So,
on the isotope, right?
yeah.
Okay.
So, you can fuse up to about iron. You can technically go a little bit higher than iron in a star, but you're getting right to a supernova at that point. So, what actually happens is when a star goes supernova, you get these waves of intense density as the supernova explodes. And within those really dense regions, you can actually have what's called the R process, which also occurs in some neutron stars, in those really densely packed gravitational neutron stars. This R process in nature is responsible for the elements that are heavier than iron. So gold, silver, one supernova actually creates more gold than is found in our entire solar system. So this is a process that we have a pretty decent understanding of in terms of the physics behind the R process, and it's responsible for the creation of the elements that are heavier than iron.
Okay. And they all happen to end up on Earth, too. From the supernova, those all elements all got here safely.
Well, within the current consensus scientific paradigm, our sun is a third generation star. So that means that you've had previous generations of stars within this basic vicinity of the universe. So the elements wouldn't have to travel very far.
Those stars are gone now.
Yes.
Where did they go?
They went supernova.
Oh.
And so they exploded, they created these heavier elements, and then a lot of that gas recondensed from gravity into our sun and our solar system and our planets.
Okay.
And just in terms of this process and the evidence to support it, the James Webb Telescope has seen these planetary disks, these accretion disks around protostars. It's taken some very beautiful images of little baby stars, little protostars with their own accretion disk, which is forming into planets. And we've analyzed the chemical composition of those disks and seen liquid water in them.
Okay. So then these lipids all got together and started and learned to break apart. And then their hydrotrophic or hydrophilic reaction caused them to get into the nucleus of a cell, or to create the nucleus, right?
Mm-hmm.
And then how did it learn to make the DNA, which is like way off the charts, more complicated than this stuff you're talking about?
Yeah, so a nucleus would be for like eukaryotes, like prokaryotes don't have a nucleus. So that would have been, eukaryotic evolution took like 1 billion years after all of this. So that's a much more complex question. But in terms of the development of DNA, again, this is a pretty open question in science, especially so far, I have not seen much publication about getting from amyloids to a DNA-based system, but we do know that amyloids at least interact with these various nucleobases and could potentially chain them up. But in terms of an exact mechanism, again, I would have to give the honest answer and say that I don't know, and I have not seen any proposed mechanism.
But until they find it, we have to tell them that God didn't do it, right?
Well, I don't think that anyone's telling any school children in class, God did not do this.
Okay.
I don't think that that's a characterization of what's happening.
Now, to the real part of evolution, okay, then we have to get to this single-celled creature. Textbooks show these family trees, okay? We're all coming from this one has a protist, okay? Do you believe this single-celled creature, whatever you want, whether it be a protist, a bacteria? Let's see. This one has this one has a protozoa.
We can just call it a single cell.
Single-cell creature. That protozoa evolved with Darwinian evolution into all the life forms we see today. Is that what you believe?
Yep. I don't see any reason to reject that other than personal incredulity. I think that's what the evidence supports.
It is incredulous, you got to admit.
I think it's amazing. I don't find it to be particularly unbelievable, especially when we have fossil and genetic evidence.
Well, we can talk about either one of those. Could this complex genetic similarities be a result of the same guy designed the code? Or maybe the same God made them all?
I would say definitely not the case, because I hear oftentimes whenever we bring up genetic similarities, the response is often to say, oh, that's because of common design. But then if we try to go the reverse process, and if we try to use common design, remember, this is the hallmark of science, to make testable predictions. If we try to use common design to make predictions, it fails. Like when we look at a dolphin and a shark, there's a common design, but they're not at all genetically similar. So you cannot use common design to make predictions, but you can use common descent to make predictions. My example is with a goldfish. If you were to say, is a goldfish more genetically similar to a human or to a shark? Well, with using common design, you might think, well, it should be more similar to a shark because a goldfish is more similar to a shark in its design. But the evolutionary common descent prediction would be that the goldfish should be more genetically similar to a human because they branched off after the sharks branched away from the evolutionary tree.
In your family tree.
Yes. And then when we actually examine the genetics, the goldfish is more genetically similar to a human than to a shark.
Okay, so I got to ask you to put you on my chart here. Do you believe you're related to a goldfish?
In a certain sense, yes.
Okay.
Because we all have a universal common ancestor.
Okay.
But I will say, in our very first debate, you already asked me this question, and it was with corn.
Oh, corn. I'm sorry. Okay.
So, but I don't know if I want to be the corn guy or the goldfish guy.
Make your choice. Which
Okay. I'll pick the goldfish.
Goldfish. Okay. Now, Honda Corporation makes motorcycles and cars. They are very dissimilar.
Mhm.
Okay. But the same company makes them.
Mhm.
Could God have made these creatures with some similarities and some great differences at the same time?
Sure.
Okay.
I mean, if you're gonna ask, could God have done this or done that? I mean, if I grant you, he's an all-powerful, omniscient being. Well, of course, yeah, he could do anything.
Sure.
So, of course, anything that you ask, could God have done this or done that? I have to say yes, because God is not a naturalistic hypothesis that we can make predictions using.
Right. I just have to stand in awe and worship and say, wow, you're amazing, God. Okay. Now, what we've observed in all of human recorded history, let's call that the last 4,000 or 5,000 years, we've observed dogs make baby dogs, and we might classify dogs, wolves, coyotes in the same category. Is that proof that dogs are related to tomatoes? We've observed tomatoes produce a variety of offspring. I think there are now 400 varieties of tomatoes, okay? But they seem to always make a tomato baby. You believe this chart here shows, let's see, I'll pick another one here. They show all the creatures related. This one has the dog and the tomato and the dinosaur all going back to a common ancestor. What's the best evidence you have ever heard of an animal or plant producing offspring that anybody would consider it's changing to a totally new kind?
So I think, honestly, the premise is a little bit malformed, because when you have enough like microevolutionary changes, those continue to add up over time to macroscopic changes. So it's like, if I could express it in an analogy, it's like you're showing me a foot ruler, 12 inches, and saying, show me a mile on this ruler. So obviously I can't show you a mile on a 12-inch ruler.
Right, sure.
But I think that, again, the hallmark of science is testable predictions. So we could say, well, look, if evolution is true, then we should find, for example, humans and chimpanzees are very closely genetically similar. At least, more than any other animals, humans are most similar to a chimpanzee. So we should expect then, if evolution is true and they shared a recent common ancestor, then we should expect to find transition fossils that have mosaic qualities of both the recent common ancestors that share qualities of chimps and humans. And then we find that with, there's lots of examples: Australopithecus, Homo habilis, Homo erectus, Aurorine. There's lots of examples of this. And this is not just with human evolution. You can do the same thing with dinosaurs and birds. You can do the same thing with mammals and more basic like reptiles, some people say. With
I know full well what they
do. So you make predictions for what transitional fossils should be found, what properties they should have, what anatomical features, and then we find them. That's the gold standard.
my question was, what has any farmer in the last 4,000 or 5,000 years observed it happening today? And your answer was a fossil. That's not happening today. What do we see? I mean, animals are having babies all over the place, okay?
Mm-hmm.
Are there any animals that we can observe today? This is changing to something else. Are these micro changes we see? They now have 450 breeds of cows that mostly man has developed from selective breeding. They're still cow. 339 recognized breeds of dogs, still dog. Has anybody ever seen, say, wow, that is turning into something else? That reptile is becoming a bird. Do we see it happening now?
So I'm going to be pretty insistent here that it's a malformed premise. So I would give the analogy, like, we all agree that languages change over time and that French arose from Latin.
Mm-hmm.
So if we look on like a single generation level, every single child could understand and speak the same language as their parents. But over time, you get from Latin to French. Mm-hmm. So no Latin-speaking parents ever gave birth to a French-speaking child. Okay. That never happened. Every single child resembled its parents in its language.
Good analogy.
So then, but over time, the slight differences every generation add up, and suddenly you're no longer speaking Latin, you're speaking French.
Right.
There was never a single generation where that change happened. It just happened over a long, multi-generational timescale.
And in that case, let's pick a number and say there are 10,000 words in the average person's working vocabulary. To change from Latin to French might have taken a couple thousand years, and changing, a few words every generation. So here they have these protozoa turning into a bird and a human. Where do we see, how many changes would that take to go from a single cell protozoa to a human?
Very, very many.
And that could happen in 3 billion years?
Yes, I think so.
Okay.
Because again, we see these changes reflected in the fossil record.
Okay.
Like, I could go all night bringing up transitional fossils, even ones that were predicted. Like, my all-time favorite is Tiktaalik. It's like, again, we made this prediction. We say, look, all tetrapods today, that is, land creatures with 4 limbs, weird tetrapods, birds are tetrapods, salamanders are tetrapods. All the tetrapods today are most genetically similar to lobe-finned fishes, like lungfish.
Right.
And so we would make a prediction. We should be able to find a creature that has mosaic qualities of lungfish, of lobe-finned fishes, and tetrapods. And then the scientists actually predicted it should happen in this layer. They predicted the layer,
right.
And then they went and they looked in that layer and they found exactly what they were looking for, Tiktaalik. It's a lobe-finned fish that has a neck and wrist bones and lungs. I mean,
are there any creatures like Tiktaalik still alive today?
No.
You're sure?
Yep. I mean, find me a fish that has a neck and wrist bones.
Okay. So we went over where life came from, and all these different kinds of life forms, all the thousands of varieties of life forms, from tomatoes to whales, came from this single-celled creature, a single-celled living organism.
Population of single cells. Yeah.
Okay. So last couple of questions, and unless you want more to talk about this, I just wanted to get your worldview. What's going to happen when you die?
The same thing as before I was born. I don't exist.
Okay, you're sure?
That seems to be the case to me. I'm not going to say I'm 100% sure, but that's what my gut is saying. Yeah.
Okay. And I made a note to myself. You mentioned at supper that you've done many debates against flat earthers. Thank you. I'm sorry they're out there and they claim to be Christian and they're embarrassing.
Yep. I would say it's a labor of love, but sometimes it's a headache.
Kansas is flat. I've driven across that, but the rest of the world's round.
Yeah.
Yeah. Okay. Well, any final words you'd like to give? This has been good. I want to understand what you believe and why. And I think you've admitted half a dozen times, or maybe a dozen times tonight, that there are certain things about this so-called process that we simply don't know yet.
Mm-hmm.
And therefore, open for interpretation. There may be more data found someday. But at least at this point, my reaction is these family trees do not represent science. They represent imagination. They draw lines on paper between these things and say, boy, look at this, boys and girls. The protozoa turned into a sponge and a butterfly and a spider. And I resent that being in a science textbook. That's somebody's imagination.
Yeah, so I think that even you agreed that the gold standard of science is verified predictions that are testable, repeatable, falsifiable. So I do think evolution not only has one or two of these, but countless numbers of verified predictions, and that's what qualifies it as science. So again, we didn't even get into some of the genetics, there's a different number of chromosomes between humans and all the other apes. So there was a prediction that at one point that 2 ape chromosomes would have had to fuse together, and that would be
Chromosome 2.
Yeah, so that was predicted. And then when we actually did the analysis, we saw that, hey, there are 2 chimp chromosomes that have the same genes in the same order as our chromosome 2 if you just line them up end to end. Okay. And we saw evidence that this chromosome 2 fusion really did happen in our genomes. We can see it written in all of our genomes.
Proof for apes.
Well, the proof that we're apes is that we meet all of the morphological criteria that qualifies something as an ape rather than a monkey. So we meet all that list. I mean, it's just a classification at that point. But the point is that evolution makes these testable, verified predictions, and that's what qualifies it as science.
Okay. My Bible 24 times in the first 7 chapters says, the plants and animals will bring forth after their kind. I predict cows will always make baby cows and dogs will always make baby dogs. You might get a big one or a little one, but I predict, based on that book right there, that animals and plants always produce after their kind. Now, what is a kind? I think a 4-year-old can tell you that a cow is a different kind than a pine tree. Okay, so we can argue about what is a kind all day long. Anyway, so I think I make the same predictions. I think we could have predicted a red shift based upon stretching of the heavens. I think we could have predicted complexity of life is too great. God had to do it. So I hold that this is just as scientific as the evolution theory. Okay.
Well, yeah, it would have to be a whole other debate on like biblical prophecy, but I just want to point out that nobody did make those predictions. Like it wasn't before we observed redshift.
That's why.
Yeah. Okay. Well, maybe you would have, but those are right now. Those are post-dictions. Okay. So those are not predictions. Like if the Bible could predict something scientific that we could observe, test, and measure, and then that was found to be the case, then I think that would count as evidence for the Bible.
Okay. Now, Donny has some questions, I believe. Donny, you there still?
Yes. Gentlemen, great discussion. I enjoyed the Q&A format and style. So good job.
I'd like all the atheists to come visit here. I think they should. It's a safe place. Nobody gets it's not a cult. It's a
Yeah, I don't have a gun to my head right now. I'm not a hostage. I had fun today, so
good. Bring them on. Okay, Donny, go ahead. Ask him your questions.
And they get the free tour, and then they get to debate you back when all's said and done. Okay, let's start at the beginning. And okay, praise the I am question for you, Grayson. A lot of the first questions that came in are Big Bang Theory related, because that was a good portion of what you gentlemen discussed at first. So, okay, so his question for you is, how is quantum information physical? It can't be physical because the universe emerged from quantum information, right? Let me unmute you real quick. Okay, you're good.
Yeah, well, I would not grant that the universe emerged from quantum information, but again, we don't have a theory for the actual origin point of the universe, so I would not grant that. But in terms of whether or not information is physical, I mean, there's no information that exists independent of a physical medium. So I would not grant that information has its own existence without any physical anything. Like, in order for you to have, a quantum information might be, is it spin up or spin down? Well, you can't just have spin up if nothing is spinning. You have to have a particle there, and that particle is physical. So it's I don't know. That's all I got for this question.
Well, let me add to that then, Donny. You probably know your phone number by heart. Where's that phone number stored in your brain? Is this physical?
Yes.
Okay, just like a computer chip, your brain is storing information.
Well, it's neurons. It's
okay.
Neural circuitry.
Okay. So thoughts are physical.
Yes. So thoughts are composed of neurons, neurotransmitters, as well as the different salt ions which are flowing in and out of the neurons that actually propagate those electrical charges in the brain.
Same thing with love. You love your dad, you love your mom. That's also physical. I mean, in your brain is something, it's not nothing emotional or.
Yeah. So it's not like it's a physical substance, but it is an event that physical things are doing.
Okay. All right, Donnie, go ahead.
Okay, very good, guys. Next question comes in from Taylor K. And the question is for you, Grayson. And so she asks, people like you say that the diversity of life comes from mutations and natural selection. But how do you account for the diversity of non-life, specifically in rocks and minerals? Grayson, go ahead.
Okay, so I feel like a lot of the questions are going to be directed at me tonight. That's okay. So in terms of the diversity of non-living things, that will be explained by the diversity of environmental conditions at their formation, or that led up to them being in the state that they are now. So, this rock has a different past history than this rock, different compositions of the environment at the time that they were formed. This explains the differences there. The big difference between the diversity of non-living things and the diversity of living things is that, there's Darwinian evolution, there's self-replication, there's variety, there's inheritance, there's natural selection. This explains diversity arising in living populations.
Thank you, Grayson. Kent, any thoughts? Anything you'd like to add?
Well, yeah, if you mean like why are the different types of rocks, there'd also be a chemical involved. I would probably agree with him on a lot of that. That we're going to see a diversity of types of rocks based upon, physical characteristics like or the attraction of certain molecules, the accretion of things like that. And so granite is different than limestone is different. I think that's what she's kind of asking, and I agree that that's a naturally occurring process. Okay.
All right, we agree.
Yay. Okay.
You guys have agreed twice because you agreed earlier on the flat Earth. I'm impressed, Kent and Grayson.
Donnie, I want to see a Kent versus a flat earther debate. I don't know if it'll happen, but I hope.
That might break the internet if we got that. Okay, here we go. Next question comes in. Now, I will say, Grayson, you're right. You're kind of in the hot seat. Most questions are for you, but Kent, my brother, one of your number one fans, is here in the live chat. And so we do got a question for you. Comes in from Creationist Crybaby. And so the question is, Kent, why do geologists find an abundance of evidence in the United States of multiple periods of rising and falling sea level that resulted in sedimentary deposition instead of one massive deluge or flood? There we go. There's Creationist Crybaby.
Okay, good. Well, during Noah's flood, I believe the Bible is literally true and scientifically accurate. During Noah's flood, you would have the world covered in water. If the earth were not were smoother, no continent sticking up through the water, then the tide would not get interrupted by banging into continents. Right now, the tide going up and down as it turns under the moon, the tide going up and down bangs into stuff and disrupts it. If the earth were covered in water, it'd be about 8,800 feet deep, 1.5 miles deep everywhere during Noah's flood. So the tide could become harmonic. And the tide would be, if the water's coming up 200 feet, which is what a harmonic tide would be on the earth, if the water came up 200 feet, all the water to fill that bump has to be coming from the sides. And so the moon is holding that bump of water under the moon while we spin. So from the east, it's constantly sucking water in at the same speed the earth is turning the other way underneath it. At the North Pole, the earth is turning 0. At the equator, it's 1,037.6, depending upon your altitude. And so if you're above sea level, et cetera. So the earth is spinning, the water going sideways at 1,000 miles an hour to fill the bump. And then when it passes beyond the moon, now the bump is emptied and sucked out the other way. So you get the constant sideways movement of the water, up, down. It's the tidal pumping during Noah's flood. Noah would have experienced about 880 tidal changes during the 7 months before the ark landed. According to the Bible, the ark rested in the 7th month. He didn't get out till the 12th month. But 880 tidal changes would cause thousands of layers to be formed. We make this little thing here. There we go. Oh, there's my vitamin C. I wondered about that. Okay. We flip this over and make multiple layers in just a few minutes. There's a better example of it here. This thing will make multiple layers in minutes. Okay, the sand art toy. Water moving sideways is what made all the layers. But in 1830, they made up the stupid idea that the layers form this way and the top layer's younger. I keep asking these guys, if the top layer's younger, where did it come from? Outer space? Every speck of dirt on the planet is the same age, whether it's 6,000 or 6 trillion. They're all the same age. So the idea of a geologic column is stupid. To say the layers are different ages is not common sense. I think if there was a tidal pumping up and down, in and out, it would automatically sort the fossils based upon their body density, based upon their habitat or mobility or intelligence. There's lots of things to sort them. Clams are found at the bottom of the geologic column because they're already at the bottom. That's where they live. Of course, you're going to find a clam at the bottom. They're the first ones buried. It has nothing to do with evolution. Birds are found on top. They're the last ones to drown in a flood. So it has nothing to do with evolution. So I think to answer your question, all the layers formed in 1 year. We have petrified trees standing up, running through all the layers. I show this all the time. Never get an answer. Polystrata fossils, other than they say, well, all those layers did form in 1 year on that tree. But this isn't enough to be the whole geologic column. That's I think, a weak answer, because thousands have been found all over the world. Petrified trees in the standing position. I think that it's a much simpler, logical explanation, taking Occam's razor. The logical explanation is probably the simplest one, is that a flood did this and the tidal pumping formed all the layers in 1 year before the tree could rot and fall down. So that's my answer. I think that the layers did form in 1 year during Noah's flood. I think we can do that. We can use science and demonstrate it happening. Okay, go to experiments in stratification video from the 1960s or so, where the French guy showed in the flumes in Colorado Springs. The Navy has a base there where they teach about stratification. About sedimentation, because they're worried about parking their submarines. You know, there might have been a canyon here underwater this year, and next year it might be filled in with mud. So they study that kind of stuff to know where are the canyons being filled in, underwater canyons. And so they say that the layers are forming sideways. You can watch it happen. It is not correct to teach this geologic column that the layers are different ages. I resent that. I think that's silly. Go ahead. You want to give a response?
Yeah, there's a lot to respond to there, but I'll try my best. So first of all, I think that the fossil record, if you object to the term fossil record, we could just say the ordering of the fossils, okay, is not sorted by these things of like density, intelligence, mobility, environment. We don't see that kind of sorting. And for example, with clams, we find brachiopods like clams in every layer, not just at the bottom, but we find them in Cretaceous, we find them in Cenozoic, we find them in every layer. And they're sorted by species type, not by body density. All the clams have the same intelligence. They live in the same kinds of environments. We see something similar with plankton. We don't see this kind of sorting based on those 4 metrics. In terms of where the layers are coming from, there are both volcanic eruptions for the igneous layers. There's weathering, erosion, and deposition for sedimentary layers. And then there's metamorphic processes for the other rocks. We can date the formation of the layers. We're not dating the material that makes up the layers. We're dating the formation of the layers themselves. Just like you and I are different ages, but the atoms that make up our bodies are all from the same age. So you're dating the formation of those layers, or dating the births of you and I when you're saying that one is older than the other. And then your other point about all these layers being formed in one big event within about a year. So there are several examples of things that could not have formed in that year, like these enormous limestone deposits. Limestone is not going to be able to form in an event like a flood. It requires very warm, stable, non-turbid water conditions to form. And even then, in the most ideal conditions, you're only going to be able to form a couple inches of limestone deposits in that time. You're not going to be able to form these huge cliffs of limestone that we see. This could not have been formed that quickly in time. And your final point about the polystrate fossils, I would challenge you to find one polystrate fossil, one polystrate tree that is going through layers that the scientific consensus say, oh, this is a Carboniferous layer, here's a Permian, here's a Triassic, and it's going through all of them. Because every time for each of these polystrate examples, when you actually look at what is the consensus date for these different layers that it's going through, it's all within a couple years of each other. It's not like they're saying this layer is millions of years older than this layer, and this fossil is going through them. If you have even one example of a fossil that's going through layers that the scientists are saying are millions of years different in age, I would like to see that, because all the examples I've ever seen of these polystrate fossils are all going through layers that the scientists agree all formed within the same general age range.
Okay, you said the scientists agree. Would I be considered a scientist?
No.
Because I don't agree with them.
Well, to my knowledge, you've never published any peer-reviewed scientific article or experiment in any science journal, or...
Is that how you become a scientist?
Generally, yes.
So in Iraq, are there any published peer-reviewed journals that publish articles against Islam?
No, those would not be scientific articles.
No. Are there any articles published in any magazines in Iraq that are against Islam, period? Is the peer-reviewed process is what I'm trying to get to. Peer-reviewed, I'm not sure exactly, peer-reviewed, let's see. Does majority prove something is true, which is what you're kind of relying on here? Are there any majority opinion articles in China against communism, or in North Korea against communism? Could it be that just like in certain countries around the world, there have always been a majority believes something, like Hitler, and you have to believe that or they're going to kill you? Could it be that there's a consensus against creation in this country, and you're not going to get published in a peer-reviewed journal if you don't believe in evolution? Could there be a prejudice, or is it, you sure it's not there?
So I would make the point that we actually have examples of scientists publishing against the grain, against the consensus, and they are publishing in peer-reviewed journals. The example I like to bring up is Mary Schweitzer. So she's the one that a lot of creationists are familiar with the soft tissues in dinosaur bones. So this was something that at the time the consensus thought was impossible, and this would seem to be something that a lot of creationists have latched onto. Now, Schweitzer has distanced herself from that. She said, "Creationists, please don't use my work," but neither here nor there. She published something that was against the consensus, and she had evidence to support her findings.
Right.
And she changed the minds of the field. She changed the consensus. So I think it is, if you have the evidence to back up your claims, I do think that you can publish them in a peer-reviewed scientific journal, and you can change the consensus if you have the evidence on your side.
Okay. And you mentioned that these trees that are petrified polystratified trees had to, the geologists are saying they formed in a year or so. They're all from the same time period.
Within the same,
Okay.
region of decades, maybe.
Okay. If someone looked at all those layers and before they found the tree, would they then have dated them all the same too? Or did the tree cause them to say they're all the same?
Yes, I am saying that even without the tree, they would have dated all of these layers to within the same basic age range.
Okay.
So if you can find a counter example to that, then I will admit that I was wrong. But until you've got the evidence of that counter example, then,
Okay. Donnie, what other questions you got? You got a long line waiting there.
That was a good back and forth on the flood. Okay, so we got a question here from George Bond. Another question for you, Grayson. So he's asking if you have ever heard of the Great Fiasco. Apparently, two different teams of secular scientists got two sets of different dates using secular labs that were doing the dating. Any thoughts on that, Grayson?
I've never heard of this being referred to as the Great Fiasco. George Bond, if you have source for this, then I'd be happy to read up on it. Like I said, I know of studies like from Dalrymple and when they repeated his experimental design of the exact opposite happening. So if you have these sources, please email them to me, and I promise I will look over them with an open mind, and I'll get back to you on that. So
Did you give your email?
My email is criticalbasedinquiry@gmail.com.
Okay, I'll make sure. Can't go ahead, brother.
That's a fair response. I've not heard of the Great Fiasco either. I have in my slides dozens of examples where they get different dates, from different laboratories. But if there's something great, I'll look that up. George, send it to me. Tech support. That's Joseph's email. Tech support at drdino.com. I get about 1,000 email a week. I can't promise I'll read it, but I'll do my best. Okay.
Okay, good stuff.
Does that go for an old man? Okay. All right, brother.
You're doing good. So George Bond has a follow-up, this time $20 super chat. I appreciate it. And this looks like it goes back to the James Webb Space Telescope, Grayson, that you were talking about at the beginning of the discussion. So he argues that the James Webb Space Telescope data has falsified Big Bang predictions. He says they're working on rescue devices at the moment as they don't have any other theory apart from the Big Bang. Grayson, do you have any thoughts on that?
Yeah, so that's just categorically false. I mean, we saw these big headlines about, these impossible galaxies and everything. But then when the spectrographic data came out, they saw, hey, wait, these galaxies are not at these high redshift values. We saw that, in fact, the James Webb Space Telescope has been seeing what's called the reionization epoch, which is a prediction of the Big Bang, where you have these very initial stars and galaxies that are starting to reionize the molecular clouds, and you have these growing bubbles of more transparent or less transparent ionized gas. And the James Webb Space Telescope has actually seen these bubbles growing, which was a prediction of the Big Bang. So the James Webb Space Telescope is basically causing us to rethink our models for galaxy formation. But our models of galaxy formation is not the Big Bang model. These are two separate models, right? The Big Bang is about the whole universe. Galaxy formations and how they formed and what role dark matter played and whether or not they were seeded with a supermassive black hole. This is all galaxy formation, which the James Webb Space Telescope is rewriting our understanding of, and we are developing new theories of galaxy formation, but it has nothing to do with the basic picture of the Big Bang, which, again, the James Webb Space Telescope was not even equipped to even test, because the very farthest things are in the cosmic microwave background. That's in the microwave end of the spectrum, and James Webb is looking in infrared. So it's not even equipped to even test the Big Bang.
Okay, Grayson, thank you. Kent, any thoughts before we move on to the next one?
Just one. The Big Bang is everything coming apart, and now he's talking about everything coming together. So they're I think, slightly contradictory, but all came together by gravity, and nobody made gravity. It was there, wasn't it?
Well, I don't know where gravity came from. I know that we have descriptions of how gravity behaves. We don't even have a perfect one. We don't have quantum gravity, so we don't even have a complete picture of gravity. But we have experiments. We know that it's a real thing. We have mathematical descriptions that are pretty good at describing how gravity works. We don't know its ultimate, what created gravity, but we do know that it's real. And in the example of the cosmic microwave background, we do know that there are these competing forces between expansionary forces like radiation pressure that's causing everything to move apart, and gravity causing everything to come together. And what they actually did is, in that initial state when everything was plasma, those two forces caused wave-like oscillations, which were predicted by the Big Bang and then measured in the cosmic microwave background. We measured, they're called baryon acoustic oscillations. They're predicted from the theory of the Big Bang, and they were measured in the cosmic microwave background. So another verified, tested prediction.
There's proof. All right. Go ahead, Donny.
Okay. So next one comes in from Boomer21, appreciate the support. Question for Grayson. If the geological column is true, then how do we explain fossilized clams on the top of Mount Everest?
Okay, so I want to clarify something about this clams on Everest claim, right? Technically speaking, maybe you'll find this as nitpicking, but they aren't technically classified as clams. They're in the same family. They're more basal brachiopods, but that's just, technically, they're not clams. But anyways, in our current understanding of mountain building, right, you have the Indian subcontinent. If we're talking about Everest, you have the Indian subcontinent and the Eurasian plate. And when they collide, right, this would even happen on Kent's Noah's flood model. These continental plates would collide, and that causes uplift of what used to be the seafloor in between them is uplifted to form the Himalayan mountain range. So this would explain why we're seeing marine fossils on the top of Everest.
Okay, Donnie, maybe you can answer. I used to be big into coin collecting as a kid. Is 10 Canadian dollars, what about 40 American dollars, 40 cents now in America?
It's a pretty wild conversion, I'll say that.
Anyway, I would agree that his model of the plates lifting up, forming the mountain ranges is, I guess, similar, only it takes a longer time. Creationist model is that at the end of the flood, the Bible says the mountains arose, the valleys sank down, Psalm 104. So I think that the clams on top Mount Everest, or brachiopods, if you want to be technical, are a result of Noah's flood. I think the whole world was flooded. I think the rounded rocks we find worldwide. I live in a gravel pit. We have trillions of rounded, smoothed off rocks in a rock tumbler. Noah's flood did that. They call it river rock when you buy it at the hardware store. No, this is flood rock. Anyway, I think the flood is a much better model than the Big Bang and hydroplate theory that they teach, or the continental plate movement that they teach. Go ahead.
That was a question for me, so I get the final word on that one, right? So
Yeah, go ahead.
with the idea of, and Donnie, I know you know all about this, but with the idea of these continental plates moving at much faster speeds during the year of the flood, of course, you're going to have a whole lot of friction generated by not just that movement, but also those plates would have to slow down to get to today's rate of continental movement. And just the friction from them slowing down is going to generate enough heat to melt the crust of the earth. So the creationists have a huge heat problem that needs to be accounted for. And I am aware of creationist teams like the RATE team that tried to address this heat problem. And basically, my understanding is that they have just said that a supernatural miracle needed to occur. God needed to do a miracle in order to get rid of all this heat so it didn't destroy the entire earth.
Well, we do have an open mic on that issue coming up on Thursday, so that should be fun. Okay, so next question comes in from, let's see here, Awesome Lawson Clips. Question for Grayson. Appreciate the support here. Got a great audience currently. So, all right, the question is, where and how do you think a person's memories are stored and accessed in a brain?
Okay, so you're making me go back to my neuroscience days for this one, but the hippocampus is largely thought to be the brain area that's most involved in like memory acquisition, retention, and recall, but it's a whole network of interlocking brain areas. It's not like you can just trace it down to just, here's where a memory is in the brain. The memory itself, the information of a memory, is contained within an entire neural circuitry. So it's not just one neuron, it's not just one area, it's interlocked through a bunch of very complicated neural pathways in the brain that are, involved. Like the hippocampus is the brain region that is involved in most of these networks, but it's going to involve other brain areas too. So that is the most precise answer that I could give you now, remembering back to my days where I have worked in a neuroscience lab for a few years in college. But,
Oh, I think we're losing you there, Grayson. Cut out for maybe the last 5 seconds. Okay, you're back.
I was just saying that our understanding of the neuroscience of like consciousness and memories is still very much in its infancy. And, I'm looking forward to progress being made in that field, hopefully over the course of my lifetime. So.
Perfect. Kent, any thoughts?
No, I think he's right on target on a lot of that stuff. I think this is a very complex pathway, and the fact that that complex nerve pathway came from a dot exploding is really amazing to me. I think we're also going to find that the heart ties in here. There's been a lot of research done on the fact that there seems to be memory in the heart and the pathway between the brain and the heart. I did a seminar on that, I did a session on that, about a year ago. It's on our channel, the Genesis Baptist Church channel. Go back and look at the YouTube there. So anyway, I wouldn't disagree with anything that I can think of right now that he said. So memory is a complicated thing. I wish mine was working better. I forgot more things than I can remember.
Well, let me just tell everyone in the audience that Kent's memory for jokes is unparalleled. This man I swear, he has at least 50,000 different jokes in his memory banks that he can bust out at any opportunity.
Kent, you need to write a joke book, brother.
My wife is writing a joke book. She said she has laughed so hard almost 3 years now. She's writing down all my jokes. It's going to be a really big book. I love jokes.
I'll buy it. That's for sure. Okay. So here we go. $5 question from Doc. Doc and Kent, you guys have had a couple exchanges over the last several months. So he's asking maybe a little trick question. He says, gentlemen, what is your favorite feathered dinosaur? So any thoughts on that? Kent, start with you.
There is no such thing as a feathered dinosaur. That is baloney. Dinosaur means terrible reptile. Okay. Dinosaur. And there are no feathered dinosaurs. That idea that they turned into birds is stupid. Real stupid. My humble opinion. Okay.
Okay. Well, there are tons of fossils where like even like a child could look at this and say, that is feathers. Like we have ample fossil evidence for dinosaurs having feathers. And I would probably say that my favorite is probably Microraptor, because it's another one of those tested, verified predictions where a scientist looked at Archaeopteryx and saw that it had a little bit of feathers on its hind legs and said, well, that's not enough feathers for it to fly or serve any functional purpose. So they guessed that it was vestigial and that there was some previous ancestor that had flight on all four of its appendages. And then they found Microraptor that has wings coming out of its arms and legs. So it's got, 2 sets of wings. And I think that's, just very cool. You don't see that nowadays. So I think it's a very cool fossil.
I'll stick with my initial analysis. I think it's dumb.
Okay. So I'll get this. Now I'll get this question up, but I'll say we still got over 300 people in the live chat, so we can answer questions till same time tomorrow. Dr. Dino, how many more questions do you want to go? You want to go 1 or 2 more and then wrap things up?
1 or 2 more on this quit. Go ahead. Is that one for me?
Yes, this one's for you. So question for Kent. What observable and repeatable evidence would you need to confirm to you that macroevolution is possible? For example, micro changes that lead to a different kind, ?
Well, we would probably have to have something with a short generation time, like a bacteria. They're born, grow up, get married, have babies in 8 hours. So in one day, you could see 3 generations of certain types of bacteria. Whereas with humans, it's a much longer generation time. So if you take something like a single cell bacteria and let it make babies, and in one person's lifetime, they can watch literally tens of thousands of generations. And they've done this. So far, they only still produce bacteria. They're not changing to anything. So here we see tens of thousands of generations in the laboratory observed that they don't change to anything but a bacteria. They might become resistant to drugs or something like that. They're never going to become resistant to a blast furnace or a sledgehammer. Maybe a sledgehammer they can get by. So we don't observe it happening. It only takes place in the imagination. The idea that the bacteria turn to everything we see today is imagined. and is always using time as they hide it in the closet of time. Well, over billions of years, it could have happened. That's not science. I want to observe it. The bacteria produce anything not bacteria. That's what happened trillions of times. Then you got to get the problem of reproduction, where the bacteria got to turn to male and female. Now you got to get one of each in the same neighborhood at the same time and at the same age, and they got to be interested. They each got to have all the equipment for reproduction. I did a whole series, Making Babies, on my channel, Genesis Baptist Church, and nobody answered any of my questions. How did this evolve? Different plants and animals, the complex way that they make babies. How did this evolve step by step? And no evolution has touched one of those. They're still up on my channel, drdino.com, or Genesis Baptist Church. So we don't see it happening. I would like to see a bacteria, which has a short generation time, turn into, let's say, a frog. I like to see that observed and dated and documented in the laboratory. That would change my mind. Go ahead.
Thank you, Kent. Grayson, any thoughts?
Yeah, again, I feel like this is asking for a mile to be demonstrated on a 12-inch ruler, but there are examples of not bacteria, but single-celled algae that they've introduced a certain kind of selection environment. They added predation, and then they observed that single-celled algae making a change and becoming multicellular.
A colony.
It's not just a colony. That's the crazy thing, because in a colony, the way that colony dynamics works is that every individual in the colony is trying to get as many resources for themselves, and they're trying to reproduce their own genetic material. But in this example, you have a differentiation, like how our cell types are differentiated. You have certain cell types that are the reproductive cells, and then you have a body cell, and you have this extracellular matrix material that's holding the whole thing together. It's not just a colony. It's an actual multicellular organism that we saw arise de novo in this study by adding a predation selection. And, you know, it's not a frog, but it's a single cell evolving into a multi-cell. And I think that is pretty good.
Okay. Does that multi-cell, I'm going to still call it a colony, does that multicellular clump reproduce another multicellular clump? Or
Yes.
do each one have to break up and start the process again? Does it have to become multicellular every time?
So each generation is multicellular, and it reproduces in a kind of similar way that we do, right? We produce single-celled gametes, a sperm and an egg,
Right.
and then those combine and create a multicellular human. In the same way, these multicellular clumps have certain reproductive cells that go off on their own and then start reproducing into an obligate multicellular organism. So it is, each generation stays multicellular, and even when you remove the pressure. So it's an obligate change.
Okay. And that is sufficient to explain the amoeba becoming a whale and a dinosaur and a human and a pine tree and everything.
That is sufficient to explain that mutation and natural selection can take one kind of organism, a single-celled organism, and evolve it into a different kind, a multicellular organism. So there are other kinds of evidences that we would have to use to support that entire picture that you laid out, genetics and the fossil record, biogeography, etc. But we could make that case using evidentiary support.
Okay, we'll do that in another debate then, okay?
Okay, it sounds good. I'm getting tired as well.
I'm getting tired too. Come visit anytime. Donnie, what else you got there?
Gentlemen, why don't we wrap it up there, as it's been a good solid hour and 45 minutes. I think this has been a lot of fun. We've had an excellent audience, some fantastic questions, and a very engaging back and forth discussion between the two of you, Kent and Grayson. We'll have to get more skeptics and critics to go over to Dinosaur Adventureland and do more of these in-person debates. I think they're a lot of fun. So any final words, final thoughts from you, Kent, and then also Grayson?
No, other than I'd like to invite everybody to come visit. It's free. You can't beat it. We feed you and house you and to give you the tour. And did you try the giant swing?
I was too much of a baby to try the giant swing.
Oh, come on.
I mean, hey, wait, you called it the leap of faith. And I just want to point out, technically, I'm an atheist. I don't have the faith to make the leap.
Okay. I understand. We'll fix the atheist part. Pray for him. Okay. Thank you for having me on your program, Donnie, and come visit. We just want to get the gospel out to the whole world. I would end, I guess, with Pascal's wager. If I'm right, If I'm wrong and he's right, there's no God, I haven't lost a thing. I've had a wonderful life. I enjoy life. I have a wonderful ministry. If you're wrong and I'm right, you're in trouble. Serious trouble.
Well, I could push the Pascal's wager back onto you, but for a different religion, like let's say Viking paganism. If Pascal's wager, if it's a valid procedure, then we should say, well, listen, you should cover all your bases. You should die in battle so that you can potentially, if Valhalla is real, right? You ought to try to die in battle so that you can go to Valhalla.
Okay. All right. Okay. Any more questions, Donny?
I don't know, but if we continue taking questions, this might turn from a debate to open combat. We might go to Valhalla.
I'm easy to get along with. Okay. Thank you for coming. And any final words? Tell people how to get a hold of you if they want you on their program or something.
Right. Yeah. So my YouTube channel is Based Theory, as in like a well-based theory. You can find me on YouTube, email criticalbasedinquiry@gmail.com. And I got to say, Kent, I like the spirit of what you're doing here in terms of getting kids excited about dinosaurs. And you have some real science exhibits, like you have the Tesla coil. That was super cool. Yeah. You've got different experiments with like focal points, acoustics. I found all of that, real science experiments. I thought that those were very cool, and getting kids excited about dinosaurs is a worthwhile endeavor. I just wish that you would use your powers to get kids excited about real science, not pseudoscience, and I wish that you would debate more flat earthers.
I'm not going to debate the flat earthers. I don't have time. I'm busy enough as it is, and we already teach the real science. God made the world, including the dinosaurs. We already teach. We got it right. So anyway, thank you, Donny. We'll have another time.
My pleasure. Kent, Grayson, the both of you sound like you've had a busy, fun day. And so we've wrapped it up with the debate. We'll let you both get out of here and get some sleep. God bless. Thanks for doing this. Okay, well, looks like it is just me now. I appreciate everybody showing up for this impromptu, in-person debate. We've been talking about it for a couple days, and we weren't 100% sure that we were going to do it or be able to do it, but we managed to sort out the details and make it happen. And so I thoroughly enjoyed it. I enjoyed the informal nature of it, and the back and forth discussion, the Q&A, and I'd like to do some more of these in the future for sure. And so we had a lot of great questions. The audience was engaged. As a matter of fact, this was Kent and Grayson's fourth debate. If I'm not mistaken, we did a full trilogy, and Joe Friday says, debate yourself. Yes, I'll pretend to be the Cretaceous and the evolutionist and go over their greatest hits, ERVs, fusion, so on and so forth. And so Jerome M., my brother, I appreciate it. I am going to go over just some announcements and reminders, okay? So this was kind of a bonus event. Typically, we don't do live shows on Sundays. We do 4 or 5 a week, but typically Sunday is a day of rest, a day to kind of do some behind the scenes work and things like that. And so this was fun. Perfect day, I think, to do it, to fit it in. And so next week is going to be another event-filled week. I am pumped for next week. Firstly, we have 2 big open mic showdowns for next week, starting with a open mic debate with Paul Price. And so it's always a blast to have Paul here. The last open mic he did with us in 2023 was the Great Genetic Entropy open mic debate. And I think that was one of my favorites. And that was a ton of fun. And we had all of your favorite critics and skeptics for that show. If I remember correctly, we had Dr. Zach Hancock, Dr. Dan Stern Cardinal, Dr. Joel Duff. We had Grayson, Luca, Jackson Rowe, Andrew Cumming. And so that was a wild open mic. Please do check it out. Paul Price, very well-rounded. And so this will be Tuesday, if I'm not mistaken. Check the channel. They're all there on the schedule. Dinosaur bones that shouldn't exist. And so what Paul's going to be doing is giving a presentation, a technical presentation, evidence for young Earth creation, It is going to be, as usual with Paul, a great presentation. Then we're going to open up the mic. So all of you critics, all of you skeptics, you know we like to keep it professional and cordial. And so make sure you're here for this show, as we will be opening it up for open mic debate. Then the one we've all been waiting for. I know I've been waiting for this. This is going to be a huge event. We've got an open mic on the Genesis flood heat problem. Yes, we've solved it scientifically, technically. And so Sam and I, Sam being Redefined Living, we're going to be hosting and moderating. We've got David M. Winsberg. In a nutshell, he published 2 abstracts at the latest International Conference in Creationism. And his abstracts dealt with the so-called heat problem. And he is currently working on, I'm just looking at the chat. Appreciate the kind words, the feedback. Blessed be he. Thank you so much. You guys are great. You guys are the life and blood of this channel. You're why I get up every morning and do what I do. It's addicting. It's fun. You guys are a blessing. So, solving the Genesis flood heat problem. David M. Winsberg, he is going to give a 2-hour. So at the conference, he was only given about 40 minutes. He's also working on putting out additional papers, as in addition to his abstracts. And so this is dealing with the flood heat problem, including Gutsick Gibbon, all of her videos she's done over the last couple of years. And so it's going to be 2-hour technical presentation. Then we're opening up the mic. Open mic debate challenge. David M. Winsberg, he's challenging all the critics. We're hoping, Gutsick Gibbon herself, Dr. Dan Stern Cardinal, Andrew Cumming, I see you in the chat, Grayson, whoever thinks that the heat problem is still a problem and has any issues with David Winsberg's presentation and arguments and solution, feel free to join. This is a big one. We're doing it for the critics. I scheduled it on the channel a few weeks ago just to give the critics and skeptics ample opportunity and time to set things aside to join. And so that is this week too. 2 epic open mic debate showdowns. We had an open mic debate showdown earlier this week as well. It was our first of the year for 2024. We did just a ton of open mic showdowns on evolution last year. That was a continuation of our evolution debate challenge series, which actually reminds me, I love this thumbnail, so I got to get it up here. We did a 4 debate series through 2022 and 2023. Actually, no, I think it was all 2022. 4 debates, Dr. Dino versus Wade the Wizard. And those were 4 of some of my favorite debates were those debates. Wade the Wizard, he's always entertaining. He makes for a good debate, of course. So does Dr. Dino. And me and Team Hovind, we are working on a DVD series. So we're currently working on 2 DVD series right now. One on the Defending Genesis Conference 2023. That's almost done. We've got the cover, working on the back cover. So that should be done soon, and it'll be available for purchase. And then we're also working on the Wade the Wizard versus Dr. Dino debate series too in DVD format. And so our goal for 2024 is to incorporate more options in terms of getting the content out, including DVDs. We've published a ton of books, but yes, we want to get into the world of DVDs, and Team Hovind is a huge help there. And so we can only do this. We can only continue doing full-time ministry with your help and your support. And so we greatly appreciate it. You can support us through Patreon. You can support us over the official Standing for Truth website in order that we can keep doing what we're doing. And so this will be the Dr. Dino versus Wade the Wizard. The saga continues. And so there's Kent. He's giving it to SpongeBob there. The famous Wacko an Atheist Wednesday. And there's Wade the Wizard in the bath making an important phone call. So this is going to be epic. This is going to be on January 31st. So we're ending the month with this one. We've also got the return of Nephilim Free. So he'll be here later this month. He'll be taking on Grayson from Based Theory. And I think this is going to be a ton of fun as well. This will be certainly an engaging debate. You don't want to miss this one. Then in the world of theology, we got some coming up as well. We got a good eschatology debate here. The resurrection of the dead. This is Dr. William Bell versus Scott Clem, Pastor Scott Clem. Full preterism. This one, there's a lot of excitement and hype for this one, and this one's coming up this week, actually. So we got quite a bit for you this week, including on Wednesday. So we did last month. We're working on another series. Matt, myself, and Kent. And so a month or two ago, we recorded a video, the first of a series. That was Evidence for Young Earth Creation. We went about an hour and a half. We wanted to compile a lot of the best evidence into a single video, but keep it somewhat short, between an hour and a half. That's done well on both channels, close to Devin. Appreciate it. I got to get that monthly fade and look fresh for you guys. So, yeah, we're going to be recording episode 2 on Wednesday. Kent, myself, and Matt. And so this time it is going to be on evidence for Noah's flood. And we're going to keep it again, between an hour and a half. And so the goal is to do about 4 or 5 of these. Evidence for Young Earth Creation. We've already done that. We've published it. It's out for people to watch. Evidence for Noah's flood. We're going to get that going Wednesday. Then we want to do 2 on evolution, refuting evolution, and maybe a 5th one, just answering questions. And so once we get all of those done, then we want to put them into a DVD series and just get this content out, get the truth out to as many people as possible. And so, okay, here's a big theology one, another theology one we got coming at you. You're not going to want to miss out on this one. Round 1 was lively. It was entertaining. That is for sure. And so Sean Griffin and Anthony Rogers, 2 powerhouses in the world of debates. And so does the Bible teach the doctrine of the Trinity? This is coming up on January 28th. As a matter of fact, that is a day after my birthday. So there we go. That should be a good birthday present. Praise I Am versus Sean Griffin's coming up too. In January, Deity of Christ debate. Is Jesus Yahweh? Should be a good one. I'm pumped for this one, beginning of February. Dr. Robertson Jennis, Phelan McFallon, both excellent debaters, both very intelligent, and they're going to be debating premillennialism versus amillennialism. And so this is the great millennium debate. Now, I do want to remind people, we've been putting out a lot of shorts. And so this provides technical content. This provides answers to challenges, objections, and questions in under 60 seconds. So if you go to the channel, click shorts. I've put out just a ton over the last couple months, and they're doing well. They're getting a lot of views. I see people sharing them around. We've shared at least a couple over on the Kent Hovind official Facebook page. One of the videos, Evidence for Adam and Eve's, at 110,000 views, something like that. So that's great. That's what we want to do, is get this content out to as many people as possible, and we want to edify. So the last thing that comes to mind is our ongoing evolution debate challenge, which we've been doing for a couple years now, because we believe doing open mics, hosting these debates are important. We want to avoid echo chambers because critical thinking is important, and we want to uphold the truth of biblical creation with our own presentations, of course, and our own lectures and content, but also in engaging the critics and skeptics. We want to give them that platform to engage us as creationists, because we want to avoid being an echo chamber. We want to give the critics and the skeptics an opportunity to debate and to discuss these important issues. And so Kent and I were talking, and we want to incorporate an additional debate challenge series. This one is titled, Should Evolution Be Taught in Public Schools? Kent obviously takes the negative, and then we need as many people as possible to take the affirmative, okay, on the evolution side. So for those interested in taking up this challenge, email, and just the evolution debate challenge series in general too, email me, standingfortruthministries@gmail.com, and I will do my best to sort out the details. I spend, probably a couple hours a day alone on my own secretary on emails. It takes a lot of work and time and effort to schedule roughly 4 to 5 events a week on all sorts of topics too. It's not just creation evolution, it's theology, soteriology, eschatology is an important topic as well. So to the critics and skeptics out there, if you're interested in engaging in debate or in our open mic events, shoot me an email and I'll do my best to sort out the details for everybody. So I think that's it. I'm glad that we got this. I'm just looking at the chat real quick, see what we got going on. You can see plenty of my own books behind me. For example, End Times Revealed, Special Creation. I go over all the scientific evidence, especially from the world of genetics for literal Adam and Eve. And I've also written a book on endogenous retroviruses. You can find those books on the website, standingfortruthministries.com, for those interested. And so, okay, I think we're good to go. We'll be back here Tuesday for our next open mic with Paul Price. I'm excited for that. And Missing Maud, appreciate it. She says, this has been the best time, Donny. Well, that's what we're here for. We are here to entertain, but also edify. And I believe these debates are edifying. It's a great way for us to sort through these issues and come to the truth, as we are being objective reviewers of these debates. So this was a ton of fun. Share it around, share it on Facebook, share it to your friends and family. And I hope everybody had as much fun as I did with this in-person debate at Dow between Kent and Grayson. Okay, everybody, Standing for Truth is out. God bless all.